In recent years, cities around the world have become increasingly vulnerable to climate-related hazards. Extreme weather events such as heat waves, floods, and prolonged droughts are no longer rare occurrences, they are becoming part of everyday urban life. These hazards disrupt transportation, energy systems, and access to clean water, while also posing serious threats to public health, particularly for vulnerable populations like the elderly and children. The growing intensity and frequency of these events demand urgent attention. To ensure sustainable urban development, cities must adopt proactive strategies to manage climate risks. This includes investing in resilient infrastructure, improving early warning systems, and integrating climate adaptation into urban planning. Building climate-resilient cities is not just an environmental necessity, it's a social and economic imperative. By addressing these challenges head-on, we can create safer, healthier, and more livable urban environments for future generations. Urban climate risk refers to the potential damage that climate-related events can cause to people, infrastructure, and ecosystems within cities. These risks are not solely determined by the severity of the hazard, such as heat waves, floods, or storms, but also by how well urban systems can adapt and respond. For example, a city with outdated drainage systems may suffer more from heavy rainfall than one with modern, resilient infrastructure. The adaptive capacity of a city, its ability to prepare for, withstand, and recover from climate impacts, is just as important as the hazard itself. Urban climate risk is therefore a dynamic concept, shaped by both environmental forces and human decisions. Understanding this interplay is essential for designing cities that are not only livable today but also resilient in the face of future climate challenges. By strengthening urban planning and investing in adaptive solutions, we can reduce vulnerability and protect communities. Geospatial data plays a vital role in understanding and managing climate risks in urban areas. By integrating sources such as satellite imagery, land use maps, and population density data, we can perform detailed spatial analyses that reveal where vulnerabilities are highest. These tools allow planners and decision-makers to visualize how climate hazards, like floods, heat waves, or droughts, interact with the built environment and human populations. For instance, densely populated neighborhoods with poor infrastructure may face greater risks during extreme weather events. Geospatial analysis helps identify priority zones for intervention, ensuring that resources are directed where they are most needed. This data-driven approach supports more effective urban planning, emergency response, and long-term resilience strategies. Ultimately, geospatial technologies empower cities to move from reactive to proactive climate risk management, making urban environments safer and more adaptive in the face of growing climate challenges. Climate data is essential for understanding how weather patterns and long-term climate trends affect urban environments. This data is collected from a variety of sources, including ground-based meteorological stations, satellite observations, and advanced predictive models. Each source contributes unique insights. Stations provide localized measurements, satellites offer broad spatial coverage, and models simulate future scenarios. Key climate variables, such as temperature, precipitation, humidity, and wind speed, are typically analyzed as time series. This means they are tracked over time to identify patterns, fluctuations, and emerging trends. For example, rising average temperatures or shifts in seasonal rainfall can signal long-term climate change. Analyzing these variables helps cities prepare for extreme events and adapt their infrastructure accordingly. By leveraging climate data effectively, urban planners and policymakers can make informed decisions that enhance resilience, reduce risk, and promote sustainable development in the face of growing climate challenges. Geographic Information Systems, or GIS, are powerful tools that play a central role in climate risk analysis and urban planning. By integrating multiple layers of spatial data, such as topography, land use, infrastructure, and population distribution, GIS enables us to visualize and assess climate-related vulnerabilities across urban landscapes. This approach helps identify zones that are most at risk from hazards like flooding, heat waves, or droughts. For example, low-lying areas with dense populations and limited green space may be more susceptible to extreme heat or water accumulation. GIS-based mapping allows planners to make informed decisions about where to prioritize interventions, such as upgrading drainage systems or creating cooling zones. It also supports long-term resilience by guiding sustainable development strategies. In essence, GIS transforms complex climate data into actionable insights, helping cities become safer, more adaptive, and better prepared for future environmental challenges. Urban areas with dense infrastructure and limited green space are particularly vulnerable to rising temperatures. This phenomenon, known as the urban heat island effect, occurs when buildings, roads, and other man-made surfaces absorb and retain heat, causing city temperatures to be significantly higher than those in surrounding rural areas. During heat waves, this temperature difference becomes even more pronounced, placing additional stress on public health systems. The lack of vegetation and open spaces in cities reduces natural cooling, making it harder for urban populations to cope with extreme heat. Vulnerable groups, such as the elderly, children, and individuals with pre-existing health conditions, are especially at risk. Addressing this issue requires thoughtful urban planning, including the expansion of green infrastructure like parks, tree canopies, and green roofs. These solutions not only help cool the urban environment but also improve air quality and enhance overall well-being for city residents. Flood risk is a growing concern in many urban areas, especially those with inadequate drainage systems and large expanses of impervious surfaces like concrete and asphalt. These materials prevent water from being absorbed into the ground, leading to rapid runoff and increased likelihood of flooding during heavy rainfall. Cities with poor stormwater infrastructure are particularly vulnerable, as water accumulates quickly and overwhelms existing systems. Geographic Information Systems, or GIS, offer powerful tools to model and predict flood-prone zones. By analyzing key variables such as rainfall intensity, terrain slope, elevation, and natural water flow paths, GIS helps urban planners identify areas at highest risk. This spatial analysis is essential for designing effective flood mitigation strategies, such as improving drainage networks, creating green infrastructure, and implementing zoning regulations. With GIS, cities can take a proactive approach to flood management, protecting both people and property from the increasing impacts of climate change. Droughts pose a serious threat to both water security and agricultural productivity, especially in regions that rely heavily on seasonal rainfall and surface water sources. When precipitation levels drop and evaporation rates rise, reservoirs, rivers, and groundwater supplies begin to decline, affecting everything from crop yields to drinking water availability. These prolonged dry periods can lead to food shortages, economic losses, and increased competition for limited water resources. To effectively monitor and manage drought risk, geospatial tools are widely used. These technologies analyze key variables such as rainfall patterns, soil moisture, evaporation rates, and reservoir levels over time. By combining satellite data with ground-based observations, experts can identify areas most vulnerable to drought and predict future water stress. This spatial approach enables timely interventions, such as water rationing, irrigation planning, and drought-resistant crop strategies, helping communities adapt to changing climate conditions and safeguard essential resources. Social vulnerability plays a critical role in shaping how different communities experience and respond to climate-related hazards. Factors such as income level, age, health status, and access to essential services, like transportation, healthcare, and emergency support, can significantly influence a population's ability to cope with extreme events. For example, low-income households may lack the resources to evacuate during a flood or cool their homes during a heatwave. Older adults and individuals with disabilities may face additional barriers during emergencies. By using geospatial tools to map these social vulnerability indicators, planners and policymakers can identify which neighborhoods are most at risk. This spatial understanding is key to promoting equitable climate adaptation. It ensures that interventions, such as cooling centers, flood defenses, or public awareness campaigns, are targeted where they are needed most. Ultimately, integrating social data into climate planning helps build inclusive, resilient cities that protect all residents, especially the most vulnerable. Green spaces play a vital role in enhancing climate resilience within urban environments. Parks, rain gardens, green roofs, and tree-lined streets are more than just aesthetic features, they serve critical ecological functions. These areas help absorb rainwater, reducing the risk of urban flooding by allowing natural infiltration into the soil. They also contribute to cooling cities by providing shade and lowering surface temperatures, which is especially important during heat waves. In addition, green spaces support biodiversity by offering habitats for birds, insects, and other wildlife, even in densely built-up areas. Integrating green infrastructure into urban planning is essential for building cities that can adapt to climate change. Beyond environmental benefits, these spaces also improve mental health, encourage physical activity, and strengthen community well-being. By prioritizing green space development, cities can create healthier, more sustainable environments that are better equipped to face future climate challenges. Risk maps are essential tools for understanding the spatial distribution of climate-related threats across urban areas. By visualizing where hazards such as flooding, heat waves, or droughts are most likely to occur, these maps help policymakers and planners make informed decisions. They combine data from various sources, such as climate models, topography, land use, and population density, to highlight vulnerable zones and potential impact areas. Risk maps play a critical role in guiding infrastructure upgrades, such as improving drainage systems in flood-prone neighborhoods or expanding green spaces in heat-affected districts. They also support emergency planning by identifying high-risk zones that may require evacuation routes, shelters, or early warning systems. Ultimately, risk maps transform complex climate data into actionable insights, allowing cities to allocate resources more effectively and build resilience where it's needed most. This spatial approach ensures that climate adaptation strategies are both targeted and equitable. Effective climate adaptation plans must be comprehensive, inclusive, and data-driven. Key strategies include expanding green spaces, investing in resilient infrastructure, and promoting public education. Green areas such as parks, urban forests, and rain gardens help absorb excess rainfall, reduce urban heat, and support biodiversity. Resilient infrastructure, like flood-proof roads, energy-efficient buildings, and upgraded drainage systems, ensures cities can withstand extreme weather events. Public education is equally vital, empowering communities with the knowledge and tools to respond to climate risks. However, these strategies must be guided by accurate geospatial risk assessments. Spatial data helps identify which neighborhoods are most vulnerable to hazards like flooding, heat waves, or droughts. By layering environmental and social data, planners can prioritize interventions where they are needed most. This targeted approach not only improves efficiency but also promotes equity, ensuring that all residents, especially those at higher risk, benefit from climate resilience efforts. Collecting accurate geospatial data is a complex and resource-intensive process. It requires advanced technologies such as satellite sensors, aerial surveys, and ground-based measurements, along with skilled personnel to manage and interpret the data. While these tools offer powerful insights into climate risks and urban vulnerabilities, they also come with challenges. One major issue is data quality. Errors in measurement, outdated datasets, or inconsistent formats can compromise the reliability of spatial analysis. Accessibility is another concern, especially in regions with limited technical infrastructure or restricted data sharing policies. These limitations can hinder effective decision-making and delay critical climate adaptation efforts. To overcome these barriers, investments in data infrastructure, open access platforms, and capacity building initiatives are essential. By improving the quality and availability of geospatial data, cities and governments can make more informed, equitable, and timely decisions to protect communities from climate-related threats. Citizen science and mobile technologies are transforming how we collect and use climate data in urban areas. Through mobile apps and online platforms, residents can now contribute real-time, location-specific information, such as temperature readings, flood reports, or air quality observations, directly from their neighborhoods. This grassroots approach not only empowers communities but also fills critical data gaps that traditional monitoring systems may overlook. Integrating citizen-generated data into climate risk assessments significantly enhances their accuracy and local relevance. For example, reports from residents during a heat wave can help identify microclimates or vulnerable zones that require immediate attention. These insights support more responsive and equitable adaptation strategies, ensuring that interventions are grounded in lived experiences. Moreover, involving the public in data collection fosters greater awareness and engagement with climate issues. In short, citizen science is a powerful tool for building smarter, more inclusive, and resilient cities in the face of climate change. Artificial intelligence is revolutionizing how we analyze and respond to climate risks in urban environments. By processing vast and complex geospatial datasets, AI systems can detect patterns, simulate scenarios, and predict climate-related events with remarkable speed and accuracy. These datasets often include satellite imagery, weather records, terrain models, and infrastructure maps, information that would be overwhelming for manual analysis. Machine learning, a key branch of AI, enhances forecasting capabilities by continuously learning from historical data and refining its predictions over time. This technology is especially effective in anticipating floods and heat waves, which are among the most disruptive hazards in cities. For example, AI models can identify flood-prone zones based on rainfall trends and land elevation, or predict heatwave intensity by analyzing urban heat island effects. By integrating AI into climate planning, cities gain powerful tools to improve early warning systems, allocate resources efficiently, and protect vulnerable communities. Visual tools such as maps play a powerful role in communicating climate risks to the public. By translating complex data into clear, accessible visuals, maps help residents understand which areas are most vulnerable to hazards like floods, heat waves, or droughts. This spatial awareness empowers communities to take proactive steps in preparing for potential disasters. For example, a flood risk map can guide families in choosing safer evacuation routes or identifying zones where emergency shelters are located. These tools are especially effective when combined with public awareness campaigns. Such campaigns educate citizens about climate threats, promote safety practices, and encourage participation in resilience-building activities. Whether through workshops, social media, or school programs, awareness efforts foster a culture of preparedness. Ultimately, when people understand the risks and know how to respond, communities become stronger, more informed, and better equipped to face the challenges of a changing climate. Geospatial data plays a foundational role in managing climate risks within urban environments. It provides critical insights into how hazards, such as flooding, heat waves, and droughts, affect different parts of a city. By mapping environmental conditions alongside infrastructure and population data, planners can identify vulnerable zones and prioritize interventions. For example, areas with poor drainage or high population density may require urgent upgrades to withstand extreme weather. Integrating geospatial tools into urban planning is key to building safer and more sustainable cities. These technologies support evidence-based decision-making, helping governments allocate resources efficiently and design resilient infrastructure. They also enable long-term monitoring, allowing cities to track the effectiveness of adaptation strategies over time. Ultimately, geospatial data transforms climate planning from reactive to proactive, ensuring that urban development is guided by science, tailored to local needs, and capable of protecting communities in a rapidly changing climate.